Hello, today I'm here with this HV ZVS driver, which is a resonance circuit intended to drive any high-frequency transformer or coil or induction heater. It's based on an LC resonance circuit, tank circuit, which is a circuit made out of an inductive part, in this case the primary of this flyback transformer, and a capacitive part, in this case made out of 5 MKP capacitors. I don't remember what's the inductance of this primary, but anyway, the capacity of this circuit is around 1.3 1.4 microfarads. These are all 5% tolerant 100 nanofarad capacitors, these red ones, so they are I'm sure they are 100 nanofarad capacitors. This one microfarad actually has a bit lower capacity, sorry, it's around 800 nanofarads. Anyway, the switching elements mounted on those switch sinks are IRFP 250N MOSFETs, which are, if I'm right, 150 volts and maybe 40 amp MOSFETs or 50 amps, and they are very good for these applications, because these switching applications, because they have some very fast switching times. This is a bit modified circuit because I added this voltage regulator, an LM317 positive adjustable voltage regulator, which can withstand any input voltage between 0 and 40 volts. Actually, it's better don't go too close to 40 volts, staying a bit less, a bit under for them. So we can accept any input voltage with this configuration from 15 to 35 volts. I'm planning to add a bypass switch for the regulator, because it usually works with a voltage drop between the input and the output of 1.5 volts. So if I, for example, drive this at 12 volts, I will get a 10 volt gate driving voltage on the MOSFETs, which is the nominal voltage where they measure all the characteristics, but it's better to be above them. Anyway, with a bypass switch I can drive it down to 10 or 9 volts. In this case I have set the input, which can be up to 35 volts, the regulator, which gives 13.6 volts, and the resistors and diodes under the resistor, under one of these resistors, to drive the gates. What can I say? Let's test it. I have optimized it in order to drain the maximum power out of this power supply, 32 volts, 10 amps, and the circuit is exactly the same in my first video. If you go to watch it, in the comments you can find an accurate description of the components, of the used component markings, and let's test it. We have quite a loud bang at the spark, actually, coming from the charging of this capacitor. Be very careful when you try it out. Don't use so thin wires. Anyway, I've tested them. It can withstand the full voltage, this insulation, but anyway, it's on the negative terminal, so it's safe to touch. I can even touch the metal. Not with the phone in my hand, because the radiated EMI will do bad things, will make it crash. Anyway, let's try it out. This is quite a thick and bright arc, and very hot. This is direct current, so shocked actually is dangerous. I mean, it will hurt a lot, especially it will burn because it's very hot, but it won't kill you. If you do it, you must know what you're doing. This may run for hours, nothing will ever hit. HV transformer because it's not ready for disturbance, but the circuit is very good, very reliable, and I was using it mounted on the aerial cell, like in this way, for 3 years, and nothing broke. Oh yeah, I can say that this inductor is made on a ferrite core taken out from a 12 volts 7 amps power supply around it with a proper wire which can withstand 10 amps at least. The input, this capacitor is the input just for decoupling, for filtering ripple, so that my power supply won't be treated too bad. That's the reason why I put this choke here, to avoid common mode interference, to go back to my power supply. And what can I say? You must be very careful because, as I said, the arcs are very hot. For example, here it is what happens on a wooden stick. You will see that you get some instantaneous burning marks instantly. I mean, that's much hotter than 5. For definition, plasma is above 5000 Celsius degrees, so it's very hot. It's not fire, it's much more. It can melt metal. That's why I put a graphite rod taken out from a pencil, because it melts anything, steel, iron, everything, it melts. And so at the negative electrode you must use graphite. That's all. Thank you for watching, and bye.